Some technicians are investigating factors affecting the braking distance of a bicycle. They start by investigating how the speed of a bicycle affects the braking distance. Figure 8 is a graph of their results, with braking distance on the y-axis and speed on the x-axis. Use the information in Figure 8 to describe how the braking distance of this bicycle changes with speed. 2 marks. I'm going to need to write 2 bullet points. So first of all, braking distance increases with speed. The faster the car is travelling, the further the braking distance. For the second mark, I need to say, but it increases at an increasing rate. So with a greater change in speed, we get a greater braking distance at these higher speeds. If it just was braking distance increases with speed, that would be a straight line graph. But as it's a curve, we can say the braking distance increases at an increasing rate. Figure 8 shows readings on a dry road. Draw a curve on Figure 8 to show how the braking distance would change with speed for a bicycle on a wet road. So the curve should look similar in shape, but with these speeds, we will have a greater braking distance as the road will be wet. So it still needs to go from the origin, from 0, 0, and we will just draw that exactly the same sort of shape curve, but higher up. So with this speed, the braking distance is greater. Describe how the technicians could develop their investigation to see how the mass of the bicycle would affect the braking distance. So this is now not talking about wet or dry at all. We're just talking about the mass of the bicycle. So we could, for 3 marks, change the mass of the bike. We could measure the braking distance. For each mass. And the final mark, we need to make sure what we're keeping the same. So we're changing the mass of the bike, we're measuring the braking distance, we should use the same speed for each test. You could also say use the same cyclist or the same force. So as long as you've talked about something, you're keeping the same. Part B says when the bicycle is travelling at a speed of 15 metres per second, the kinetic energy of the bike and the cyclist is 9,300 joules. Calculate the mass of the cyclist and the bicycle using the equation. So here the mass equals 2 times the kinetic energy, 9,300, divided by 15, the velocity squared. Be really careful here. Use brackets in your calculator. Your calculator isn't clever enough to work out what bit you're squaring. So I would then write 2 times 9,300 divided by what 15 squared is. So I put that into my calculator, that's 225. So you get a mark for that bit as well. And then the final mark, putting that into your calculator, is 83 kilograms. Describe the energy transfer that takes place as the cyclists brake. 2 marks. So the energy transfers that take place. The kinetic energy decreases as they slow down. Remember, kinetic energy is to do with movement, so if we're slowing down, we're getting less movement, less kinetic energy. For the second mark, so where's that energy going? So that's thermal energy increases. So as that bike brakes, heat up, and the friction between the wheels and the road causes heat, we get thermal energy increase, and that then spreads out or dissipates to the surroundings.